Yep, microphone is in. That's good. And we are going to roll our way down here to where we were talking about the different colored filters. All right. And I can't quite remember which one we were on. Which filter were we on when we ended at the end of the day? Which one were we dealing with? We were right at the double one, weren't we? Actually, we started a double one. We didn't do a magenta, did we? So don't worry about writing this one down, but let's analyze what possible things can happen. Again, I'm going to grab some of these filters that I have here, and I may not be able to hold up a magenta filter because I don't think I have a magenta filter that's large. I do have a magenta filter here, orange, purple, magenta. I do have a magenta filter here that goes into my slide projector. So there you can see a magenta filter. So again, using our additive color theory, right? Using our ability to think about what colors we need to see in order to have a certain perception, in order for my eye right here to see magenta, what has to get through? What has to get through to my eye? Yeah, go ahead. No, Dolan? Blue and red. So blue and red are getting through, and green is blocked. So it seems almost counterintuitive, but the color that we don't see is what's being blocked, and that's what's being stopped. So it is appearing magenta because the red and the blue made it through, so the green light was subtracted. And at the very end, we talked about what happens if we were to double up or triple up some filters. So again, let's think this through. I think maybe you drew this one in, and I'm going to draw it in again. The red filter lets what color through? It lets red through. So the red filter stops green and stops blue. A blue filter only lets what color through? Blue. And now there is no blue, so it stops red and stops green, but because there's no blue, yep, it's going to appear black. This is going to appear black. All right? And we did that with these two little slides here, but it wasn't completely black. All right? Now, from that point of view, you might say, that looks black, right? You might say that those overlapping look black. But if we brought it really close, whoa, that is pretty black, isn't it? Did we use those two yesterday? Yeah. That's quite black. That one works out quite well, doesn't it? That gets you black completely. All right, so let's try a couple more combination ones and see what we get. So what if we have a cyan filter and we have a yellow filter? So let's think about what the cyan filter lets through and what the cyan filter blocks. So what does a cyan filter let through? What does a cyan filter let through? Pat? Blue and green. So a cyan filter lets through blue and green and stops red. What will a yellow filter let through? What will a yellow filter let through? Red and green. So it's going to let red through, but that's blocked. It's going to let green through, and it's going to block blue. So if I overlap a cyan filter with a yellow filter, what should we see? Yeah, Zach, we should see green. We should see green. And that's kind of goofy. That's kind of counterintuitive. But that's the light that's common to both. So what do we have here? I don't know if I've got cyan and yellow. I've got a yellow one here, but I don't know if it's primary yellow. Cyan, they call it blue-green. Here I've got blue, green, and yellow here. So there's blue, green, and yellow. We should maybe put this on the projector. If I put them over, does it look green? Yeah. Can you see it? So there you can see that it does that. It lets that green through because that's the only color that is common to it. Can you see it? Can you see the green? So that's the only color that's common to the two. So that's how you would analyze how it goes through. Okay, now, mixing paints. Don't write this down. Don't write it down. Because we're going to just continue on to the bottom side of the sheet. We're going to analyze the paint situation. Mixing paints, right, adding some yellow to some cyan, is really exactly the same as overlapping filters. Because paints and pigments, really we're talking about the term pigment. Anything that colors the wall like paint, or anything that colors fabric like a dye, right? Pigments absorb colors just like filters absorb colors. So we analyze a reflective color the same way as we would analyze a filter scenario. We want to ask ourselves, you know, what color does a red object reflect? Well, what do you think? Red. And so what colors are being absorbed by my red coat? And what are all the rest? There's only two, green and blue. Because when it comes to color theory, we're only thinking about the three primary colors. So it reflects red, but it absorbs green and blue. Just like a red filter allows red through, but it absorbs green and blue. The only difference is this is transmission of light and this is reflection, but it's the same idea. So let's now analyze some paint scenarios. So again, you should have some, you know, and this is just a cylinder, and my idea was to represent the cylinders as like a can of paint. Yep. Not for the additive color theory. That's for something else. It could be paints. That's a different color theory. We're analyzing everything based on this color theory. So there are different ways in which we explain color. We're explaining it using red, green, and blue because that's what our eyes are sensitive to, and that's the way physics likes to analyze color theory. Okay? So you should have pictures down at the bottom of some paint cans and various things. So we're going to shine some white light onto some white paint, and it seems kind of silly, but what's it going to look like? It's going to look white. It's going to look white. And why is that? What did it do with all three of those colors? It reflected all three of the colors. So the red was reflected, the green was reflected, the blue was reflected. So we can see here the red, the green, and the blue are reflected. If my eye was right there, it would gather up all those colors and we would see white. That's why white in the summer is a nice cool color, because all of that incoming light energy from the sun is reflected away and you don't heat up. All right? So let's now shine some red light on some white paint. So the white can reflect everything, but there is only red light. So how will that appear? Yep, it'll appear red, because the red light is the only thing that's there, and therefore it will appear red. It has the ability to reflect all, but if there's only red light on it, it should appear red. All right? Now if I shine some yellow light on some white paint, well, again, what can the white paint reflect? What does the white paint reflect? Green and red. It has the ability to reflect all, but there is only green and red. Green and red, that one's the red one, that's the green one, and therefore it appears yellow. All right? Now, I don't know what my next example is. I'm hoping it's something that's a little trickier than what we've been doing. All right, so now let's change it around a little bit. White light on some blue paint. What is happening here to my three colors? I can hear the buzzing, guys. I can hear the phones buzzing. I'm just saying I can hear it. I know you're giving me a grin. You're kind of going, oh, baby, Sanders just gave us the big speech. I hear the buzzing. I've chosen to ignore that one, but just relax, all right? Let me just relax. So, because I need to get my work done. If I stopped every time, I'd never get done. What's going to happen here to my three colors of light? I've got red, green, and blue falling onto some blue paint. What's that blue paint doing? What's it doing? Logan, what's it doing? It will absorb the red and green, and it will reflect the blue, and therefore we see blue. So just like a blue filter absorbs the red and green and lets the blue through, this pigment, or blue shirt, or blue paint, or blue wall, it reflects the blue. Now it's different than your screen. You guys, some of you guys are looking at the PowerPoint and you're seeing a blue screen. That's different. Where's the light coming from on your screen? It's coming from the device itself. There's a backlight there that is producing that blue light and shining that pixel of blue light out. Okay? All right. So that's different. It's not being reflected. It's actually a luminous substance. White light on cyan paint. What's being absorbed and what's being reflected? What am I putting down as the X, and what am I putting down, how am I extending my rays? Yep, Bella, what do you think? Blue and green light reflects. The red is stopped. So we've got our green and our blue. It appears cyan. Okay? So it's all about what is being absorbed and what is being reflected. What if I shone some red light onto some green paint? Some red light onto some green paint. What can the green paint reflect? What is being absorbed by the green paint? What kind of light did we supply with it? How should it appear? Tyson, what do you think? What does green paint reflect? That's an obvious question. What does a green paint reflect? If a green paint reflected red, it would look red. But this is green paint. It's going to reflect green. I have red light shining on it. Green paint doesn't reflect red. It absorbs red. It stops red. What kind of light is going to come off of this thing? No light is coming off. It's going to appear black. That should appear black. In a moment, I'm going to set up the projector, and we'll project it onto the wall, and we'll change some colored lights, and we'll put some different colored things in front and see if this actually works out this way. Here I'm just telling you some theories, but in a moment we're going to try it on some real light. I have cyan light on yellow paint. So again, you've got to ask yourself, what colors can cyan reflect? What colors can cyan reflect in order for me to see cyan? What colors can cyan reflect? Riley, what do you think? It can reflect blue and green. So what's it going to do with this green one? Reflect it. What's it going to do with this red one? Stop it. Absorb it. Yep.
Cyan light in yellow paint.
Cyan light on yellow paint. Oh, sorry. Well, I've got red. Oh, look at that's backwards, eh? See, I've got red and green. That should be yellow light on cyan paint. That's a typo. Because obviously I've got red and green, that's yellow light, right? So that's a typo. Good catch. I must have screwed that up. So the cyan paint reflects blue and green. It can only reflect the green. What should that look like? Should look green. It should appear green because there's the only light there. Okay? Let's do I don't know how many more. How many more have I? Oh, This is just me putting blanks on there. How many blanks have we got left on our page? We got any blanks left on the page? There's still 5 blanks on there. Did you take a look there, Brett, for me? How many blanks? Just like resizing? It's 5 blanks. So the idea of the blanks is for me to set some actually up and see them. So let's try that for a moment. First, and I haven't tried this before, I'm going to try to create a black background. And it's going to have some trouble because this is my like emergency blanket like in my car. So I'm going to like put some magnets on it. Hopefully they don't fall over. Oh, this isn't working the way I wanted it to. I was hoping magnets would hold this up. I would need thousands of magnets at this rate. Okay, that's a failure. Hold on, I got one more plan. I've got a bunch of super strong little magnets. So we'll see if the super strong little magnets will hold it up. Again, I should have tried this. Not very good today. Let's try these strong guys. Yeah, I could. I don't know whether the tape would hold. Oh, these magnets are stuck together. They haven't been apart for a long time. That's no good. Now I'm not going to have very many of them. There's one. There's one. They are, but they're stuck together because we haven't had them apart in a long time. So I'm not able to get as many of my want. I've got like 15 of them stuck here, but they're so strong that they're not coming apart. But I think we might have enough. Oh, really? Come on. That's fun. Let's get our screen up here. Let's get our projector. Okay, let's get some electricity. That's going to happen over there. And let's plug this in here. And let's start with, what do we got here? That was blue. Let's start with a cyan. Oh, that's absolutely no good. Because the cyan looks cyan, which means my black sweater or my black blanket is really not very black. Because if it were truly black, actually that's not bad. That's not bad. Because if it were truly black, how should the screen look if I reflect any light on black? It should look black because I've taken all the light away, right? But that looks, well, that doesn't really look cyan, does it? It almost looks green like the chalkboard, doesn't it? So it doesn't look absolutely cyan. So I'm going to need an assistant here. You can be my assistant? Okay, Pat, come on up here. I want you to shut off the light like that and then turn it on when I ask you to turn on. Right? See what I mean? So it's just a switch here, left, right, there. So just shut that off for a minute. And I'm going to bring up some white light. And let's take something like this Pringles can. And actually, first we'll do it with the pen top. All right? And so I've got a yellow pen top, right? White light is striking it. It looks yellow, which means, what is it reflecting? If it looks yellow, what is it reflecting? Red and green. In a moment, I'm going to shine some cyan light on it. What colors are in the cyan light? Green and blue. So what should the pen top look like? If it's yellow and it reflects red and green, but I'm going to shine blue and green on it, how should the pen look? it should look green. So I'm going to shut this off, and you can turn yours on. Is that a fail? How does that look? Does it look green? It looks kind of green. I'm going to turn this back on. You can turn yours off. Oh, there, that looks quite yellowish. Okay, turn it back on. That looks kind of green. Okay, flick it back off. Let's try the Pringles can. You know what I'm wondering is that they're not pure yellows. Let's try the Pringles can. I got all kinds of different colors in here. There's even like some magenta and in there. Does that count as magenta? I guess it almost looks like magenta. What colors are in magenta? Red and blue. I'm going to have the cyan light. What might the magenta look like? It might look blue because that's common between the magenta and the cyan. So our yellow might look green and our magenta might look blue. Okay? Go ahead, fire it up. Oh, now that's interesting. Look, what's that? Well, look at this here. How does that look? That looks purple. Here, let's shut your light off. And you see how it looked magenta there? It kind of looks magenta. So go ahead, turn it back on. So I would say that the magenta turned kind of nice and bluey purple, right? You must agree with me. That Pringles can looks much different than that Pringles can, right? Because it does look quite blue. I have no idea what's going to happen to this orange guy. I have no idea. Let's, what did the orange become? Lighter orange. Almost ready, but it looks orange. Okay, let's swap out the slide for some other colors. Let's try a primary color. I'm going to sneak in behind you there, Pat. Just back up for a second. I'm going to swap it out. I'm going to put in a primary color this time. So instead of there being two color options, there's only going to be one color of light hitting it. And let's try a nice primary blue. So we're going to go with a primary blue. All right, put that in there. We got primary blue coming on there. That looks good. All right, so I'm going to shut that down. You can turn that. You can leave the fan on, though, as you're doing that. So let's try this. So again, the magenta has blue and red, and I'm going to shine blue on it. So now it's going to actually, you know what, I'm going to set up a second one here. Let's put a primary red in this projector here. Tyson, you can run the second projector for me. That'd be great. So let's set up a primary red. Oh, that was a primary green. That would be a good one too.
I got you.
You're gonna run both? Nice. Nice. Come on. Don't fail me now, you silly machine. It's an old. Oh, you silly machine. It doesn't seem to like that red. I might go back to primary green. Ah, that slide was too big. So turn that one on. Oh, where are we hitting? Down there. I need another book of some sort. Okay, let's check another book of some sort here. Oh, nice. So we're going to shut this one off for now. And you shut both of them off for now, actually. Okay. So let's take a look at the Pringles can and we'll do this one first. What is that one? Primary blue? Primary blue? That's fun. Okay, so you can shut that one off. Okay, so let's take a look in primary blue. Go ahead. Oh, that's kind of odd. Notice the writing on the Pringles and the chip has gotten very dark. So there must be a lot of red in that. Try the primary green. Now look at the magenta. How would you describe that? Black. So that magenta, which we thought was magenta, which was blue and red, now when we illuminate it with just green, you can see that that's looking pretty black. That's looking pretty black. Excellent. Turn on both. Turn on both. That's kind of fun. You can see there in the blue, we've got the blue, and in the bottom, we've taken a distinct amount of the color away from that thing. Actually, keep them a little separate. See how you can see how the blue transitions into black? All right? That's kind of fun. Okay, so just off for a minute. Now, you got the blue off too?
Yeah.
Okay, so now my lab coat is obviously primary red. Well, I'm hoping it's primary red. So if we shine just some blue light on it, how should it appear? It should appear. Okay, well, let's take a look. Okay, red coat, light. Oh, it does look a little red there. That means it's not primary red, because it should have appeared black. It should have appeared black. All right, try the green. Switch over to the green. Oh, and that also has some yellow in it. So my coat isn't primary red. My coat is not a primary red. Okay, let's see if we can find a primary red. Something that's primary red. Actually, you know what would be perfect? That Big Bang Theory shirt would be awesome. Can you stand up here and stand in front of it? No, you can't? That's okay. I've got my Big Bang Theory bobbleheads here. All right. Let's take a look at what these guys look like. Okay, give me some light. I don't care which one. That definitely became black. Oh, look at that. Looks almost black under both conditions. That red looks black under both conditions, and that was a red to begin with. So again, let's get our lights back on. So there you can see there, that looks very dark. There we've got them all kind of looking down there. Oh, there's definitely some yellow in that. Can you see? So look at, you can see Wolowitz is all nicely in red, and Raj is in the purple here. So and green for Sheldon, and you can see that red and look at the blue and the green. They all look almost the same. There is a little bit of blue in there. Let's see if we move up here. Look at there. You can see Raj's blue now stand out. You see the blue in Raj's shirt. Same in Penny's shirt. You can see that blue kind of come into play. And because we have no red, we can't see any of that. Let's turn on that other projector. You can turn on the middle projector. And let's just put a primary red in front of it. I got to find a primary red. Purple. Primary red. Orange. There's a primary red. You're going to have to hold that one in front, just like that. You see what I mean? Because it doesn't have a projector thing. So fire up that thing. Let's see. Go ahead with the primary red. So again, down here, turn on the other two. You don't have to hold the other two. Just turn them on. Okay. So here's how they look in the primary red. Everything's looking very red. Actually, you can leave that down. I want to just transition into the green. Into the green, you can see that looks completely different based on the light that's reflecting off of it. And then into the blue, oh, you can see some mauve in there. The blue-green, that looks good. And can you now bring the red up now to overlap it so we can get all three of the light colors in there? Yep, a little higher. Perfect. And there you can see they look almost normal again. The white package even looks white. So I can add that red, that green, and that blue, and I can get them. But on their own, we have definitely some different colors that we perceive. Excellent. You can shut that off. All three of them. You can have a seat. Okay, we're going to put the bobbleheads back where they sit. All right. And we'll turn on some lights. Okay. Now, at this point, I'm done the unit. We've talked about everything that we're going to talk about. Tomorrow, I'm going to do a little review at the beginning, like I always do. I will then supply you with a review sheet to work on, as I always do. It's going to be on Google Classroom. And if you have to draw any ray diagrams, this time I'm going to make you draw your own ray diagrams to do some practice. All right? In other words, I'm not going to give you that nice sheet because there's only a few that I'm going to get you to practice. So for the rest of today's class, I've got a Bill Nye that is basically a review of all the different stuff that we've done on light. It is old school. It is like circa like late 1980s, early 1990s, but it is pretty good. So we'll do that. So you can pack up your stuff and you can put any iPads away, etc., etc. Can you just carefully pull that cart that way for a moment there, Josh, just so that people can get by? Again, let me have your styluses here, stylus container here. Thank you very much. Yeah, that works pretty good. The magenta on that can was excellent. Yeah, right in there is perfect. Thank you, sir. Okay, I do have to stop my recording here because I am still recording.
No. Check this and all this.